So yes, I'm Thomas. I'm from France, so I will have to speak in English. I hope it's fine. And thank you for welcoming me here today. I'm going to talk about BGP, BGP monitoring, and BMP today. So probably most of you know BGP is the main interdomain routing protocol used today. And to monitor BGP and to understand internet routing, it's important that we collect BGP data from actual BGP routers. So we can build monitoring tools like Kaida's IceRank, like BGPlay, and there are also many commercial tools that use this data. So each router that share the data, it's like a satellite in a sense. Each of these routers, they see a partial view over the internet routing ecosystem. And it's when we combine all these routers that we can have a more global view over internet routing. So it's like satellites. Each satellites monitor a small portion of the Earth's surface, and then when we put them all together, then we can really monitor the Earth's surface more globally. So historically, there are three platforms that collect BGP data. It's Ripris, Radius, and PCH. Probably you know them already. Recent Radius, for instance, they are connected to about 1,500 BGP routers each. And then they share the data with the community. So these routers, we also call them, by the way, vantage points in this presentation. So today I came here to present you a new BGP data collection platform that is called bgprods.io. It's a new platform that we built at the University in France, at the University of Strasbourg. And we say it's a new platform because we just launched it about a year ago. And probably you may wonder, why did we decide to build yet another BGP data collection platform when there are already Ripris, Radius, PCH that exist and that seem to work rather well? Well, we decided to build a new platform because it's not so easy to build, maintain, operate such a platform. And typically, there are two main objectives that we want to achieve when we operate such a platform. We want to have high coverage, but we also want to keep the data as much as possible. And the problem is that these two objectives, they are often not easily compatible. They are conflicting, right? Because high coverage, it's expensive because we collect a lot of data. Keeping it forever, it's also expensive. It takes resources. So usually what happens is that we need to prioritize things. And typically what happens with Ripris and Radius, for instance, is that they prioritize data retention. So they really want to keep the data forever, and this is extremely useful because researchers, for instance, they love to go back in the past, do some analysis, and this is very useful. The problem is that then recently they switched to a selective peering policy, meaning they don't want to peer with every router anymore because this is just too much data, especially if the data is redundant, for instance. It's just too much data, too much resources that they need to take for that. So yes, so now perhaps not anyone anymore can peer with them. So this is how they prioritize things. So today, for instance, recent Radius, they only peer with about 1% of the autonomous system. It's good because this is a very important data set, but it's not enough to have very highly accurate monitoring tools. So with bgprods.io, what we decided to do is to do this the other way around. So we want to prioritize coverage as much as possible, even if that means eventually we just discard the data. Our goal is really to have accurate, real-time, and short-term historical monitoring tools. So we also say that it's a next-generation BGP data collection platform because we try to improve the collection of the data so that we can enable high coverage, but also we try to improve the distribution of the data to the users so they can use the data effectively. And this is what I'm going to show you now in this presentation, so how we improve both collection and distribution of the data. So let's start with the collection of the data. So we rely on three key ingredients to increase the coverage of the platform. So the first ingredient is automated peering establishments. So what does it mean? It means that we really try to simplify as much as possible the connection to the platform. So if some of you want to contribute data, it's extremely simple. You just have to go on the website, and then you can authenticate using your peering DB account. So we know which AS or ASCs you operate, and then you can submit a form where you indicate what is your IP, which ASN you want to use, and then our infrastructure will set up a session, or will accept a session from your router. And this is all automated. It takes 2 minutes, so we hope that it will facilitate and motivate operators to connect. The second ingredient is that we also aggregate data from all public BGP repositories. So what does this mean? Well, actually, what we found is that we don't want to try to compete, against the existing platform that exists, so RightPrease, RoadViews, and so on and so forth. The goal is not to compete with them, because each of these platforms, they have strengths and weaknesses. And we try to summarize this in this table. So for instance, here you have 4 platforms that exist and that share the data publicly. And you see here, for instance, in terms of peerings, they each have strengths and weaknesses. So for instance, some of them, they allow physical peering, some other, they allow remote peerings. In terms of how they share the data, it's the same. They have strengths and weaknesses. And so now you can add a new column here for bgp-ros.io. Again, we have strengths, weaknesses. For instance, one of our weaknesses is that we don't support physical peering. We just do remote peerings for now. But it's when we looked at this table that we realized the goal is not to try to compete against this platform. Instead, we want to embrace all this data. So what we do is we just take all the data from all these platforms and we put it into one single repository, which is our database. So if you go on our website, you can see a table that summarizes all the data that we collect. So all the vantage points that we have from bgp-ros.io, but also from RightPrease, RoadViews, PCH, CGTF. And you can use all this data through our interfaces. So when everything works well, bgp-ros.io stores data for about 5,000 vantage points. And on this map, you can visualize where these vantage points are located. So you can see that there are some regions in the world that are pretty dense, and there are some other regions that are where there is a lack of vantage points. Here in this country, in Czech Republic, what happens? Well, we count 7 vantage points in total. There are 6 connected to RightPrease. And actually, there is one that is already connected to bgp-ros.io. It's AS204917, so thank you for that. Maybe the operator is in this room, I don't know, but this is great. It provides a full feed IPv4. So this is good, but I mean, more would be very welcome, because it will make our BGP monitoring tools more accurate in this region of the world. Okay, so now the third key ingredient to increase coverage, it's BMP. So here I'm going to take a little bit of time because I think this is interesting. So the problem here is that even when we finally convince a network operator to connect with bgp-ros.io, for instance, well, that's going to be done through a BGP session, and BGP typically hides routes. Okay, so what does it mean? Let's take a very simple example. We have a BGP router here, and imagine this BGP router is connected to 3 autonomous systems, IS1, IS2, and IS3. So this BGP router is going to receive BGP route updates from these 3 autonomous systems. And when these updates they arrive, they might first be filtered by the inbound filters. The routes that are permitted, they then go through the decision process, and then the RIB is calculated, and finally the best paths are announced to the peer if they are not filtered by the outbound filters. So that's the typical BGP processing pipeline in a BGP router. And now, if you assume that this router is connected to a BGP data collection platform like BGP ROS.io or RIS or RODViews, what happens is that we will use a BGP session to connect with this platform. So only the best paths that are not filtered are going to be announced to that platform. This is good. This is useful data. The problem, however, is that all the routes that are denied by the filters, and also all the backup routes, they are not going to be announced over the BGP sessions, so users will not be able to use these routes. And this is really a pity because the operator is willing to share these routes. It's just that these routes, they are not announced over the BGP session. And perhaps in this set of routes, we could see hijacks, route leaks, or whatever. It's an interesting data set. We just don't have it. OK, so BMP here can help. BMP stands for the BGP Monitoring Protocol. And it's good because, first, it can provide all the route updates on a per-peer basis. And second, because it can also provide the route updates at every stage in the BGP processing pipeline. And on top of that, it's also very simple to configure. So what does it mean? So let's take our previous example here. We can see actually that there are 5 stages in the pipeline here. The first stage on the left, this is where all the route updates, they just arrive in the router before they are filtered. And then there is another stage after the inbound filters. Then the third stage, it's the best path in the RIB. And finally, there are 2 other stages before and after the outbound filters. So now if the operator decides to connect with a collection platform with BMP this time, the operator can really decide for which stage in the BGP processing pipeline the router should export the data. It can be one stage, it can be multiple stages, this is all configurable. In the context of BGP ROS.io, what we recommend to do is to export the data only for the edge in play stage. This is the stage on the left here, because this is just where we will see all the routes before they are maybe filtered. And besides, if you do this, it will also prevent users to infer your routing policies, and that's probably something you want to do as well. So this is what we recommend. So what happens now if you do that? So if you do this, the collection platform will receive the data, the BGP routes that are actually sent by IS1, IS2, IS3. So it's like if the collection platform had a BGP session with IS1, IS2, and IS3. It's the same data, but instead of 3 BGP sessions, now we just need 1 BMP session with that router, and we get this data. So this is where BMP here can really help. It's less efforts for operator because it's just 1 BMP session, but it's much more data for users. OK, so now I will explain you how we try to also better distribute the data. Because collecting more data, it's useful, but it's not so useful where users are not equipped with the tools to process this data. So of course, we provide an MRT archive. This is like the standard way to share BGP data. But MRT files, it's not simple to process. And so we decided to have an API instead. An API that we made it sort of quick, flexible, fast. But we realized that people, what they want is like more like dashboards. They want easy things to analyze. So we built dashboard, and this is just what I want to show you quickly now. So the first dashboard is a sort of an IS explorer. You can see the characteristics of the different ISs, the prefixes that they announce, and so on and so forth. So we use the data we collect, by the way, to build these dashboards. But with these dashboards, what we really want to do is to bridge the gap between the users and the raw data. We don't just want to have dashboards so that you can see some alerts. Or what we really want to do is to bridge this gap between users and the raw data. So what we do is, whenever we do an inference, for instance, we infer that one RS is a provider of another or a customer, we really want to let user know which data we use to make this inference. And this is what you can find in this dashboard, for instance. Here we really show the IS path that we collected and that we use to infer that, for instance, that IS is the customer of Hurricane Electric. So this is really the goal of these dashboards. We also have an IP prefix explorer, which is like a giant looking glass. So if you go there, you will see all the routes from all these vantage points towards a particular prefix. And on the right side here, you have some filters that you can use. So for instance, you can use ISPath regular expression, community regular expression. You can filter based on the country of the vantage points. So it's like if you do like SQL queries directly in our database, but you just go through our dashboards. Lastly, we have the vantage point explorer, which you can use to browse the vantage points. So on the left here, you have the networks that have vantage points. You can click on one of these networks, then you see all the vantage points, and then you can select one of these vantage points, and you have some statistics, some graphs, and you can really see the raw updates and the rib of all these vantage points. You can also browse the BMP-derived vantage points with this vantage point explorer. So today, for instance, we are connected to 7 autonomous systems using BMP. And for instance, here, the first network, it's Nokia Labs, which is connected to BMP with us. And this single BMP session actually enables 111 vantage points. So it's like if we were connected to 111 networks using BGP, but instead we just have one BMP session. So this is really, really cool. And now we have 7 BMP sessions, yes, as you can see here, in total. That makes more than 300 vantage points, something like this. And finally, to conclude, I just want to say that if you operate an IXP, you can also connect to BGP routes.io with BMP from your route server. And this is actually what happens here for this network. It's a small IXP in France, and then they connect it to us from their route server. And that's possible because Bird and FR routing, for instance, which are the 2 main software routing stack used today for route server, they both support BMP pretty well. So yeah, that would work as well. Yeah, thank you very much. And yeah, if you have questions, or you can also find me after during the break. I would be happy to help.
Thank you. Is there any question? Oh, there is over there.
Hello. And do you use BGP multipass extension?
We don't support it for 2 reasons. So first of all, so you mean the AdPath thing, or
Yeah.
So first, if you use AdPath, you will not see the routes that are filtered, right?
Of course, but it's still.
It's still better. It's still better, but we prefer to go directly straight to what we think is the best, which is BMP. But I agree, it could help a little bit. But there is another thing is that if you use AdPath, you don't know from where exactly the data is coming from. So you can imagine you have 2 peers from the same AS. You don't know from which peer the data is actually coming from. Whereas with BMP, you do know this information.
Yeah, of course, BMP
right.
is better, but. Okay.
Yeah. So, but you are right. It could help.
Yeah. Do you use NLnog as a source, or?
The NLnog looking glass, you mean?
Yeah.
Unfortunately, no, because we don't have access to the raw data. But if they
do not share it publicly.
So what they share is a looking glass, but what we need is the raw data. So for instance, we need either an MRT archive. That's what happens, for instance, for PCH. We are getting the data from the MRT archive, and then we put it into our database. For RightPris and RoadViews, they have real-time streams, so we connect to their real-time streams. For the NLnog looking glass, as far as I know, they just put the data on the dashboard and that's it, so we cannot really get it from there.
Thank you.
Thank you. Yeah, and I don't think we have much more time.
Thank you.
So thank you very much, Thomas.